right, hey friends, I wanted to record a quick video about one more specific type of logarithmic function that you all need to know. And if you remember in the last class, we saw that if I have a logarithm that is log base a of x, that I can rewrite that in exponential form, and that would be x is a to the y. And what we're doing here when we use logarithms is we're actually trying to find out what this exponent is right here. So we use a logarithm when we're searching for what the exponent is that we've raised another number to, okay? And you guys have practiced this a little bit now. But what I want to introduce you to is a very specific type of logarithm, and it's so specific and it's so famous and it's used so many times that it has its own name, and that's called the natural log, or the natural logarithmic function. And so you may remember that when we studied exponentials, we talked about a specific type of exponential, and the exponential we introduced was this one, that f of x equals e to the x. And e is this number that you remember we found the approximation for was 2.71, so on and so forth. And e was a specific number that was approximated by this series that we looked at. And the natural log, which is written like this, y is the ln of x, and that's pronounced, you can read that as ln of x. The natural log, or ln of x, is the inverse to this function here. That ln of x and e to the x are inverse functions. So in other words, we could write y equals ln of x, and if I wrote that in exponential form, that would be x equals e to the y. So again, this is the logarithmic form. This is the exponential form. They're inverses of each other. These two statements mean the same thing, just written in two different ways. Okay, and so I'll highlight that here, that this is the logarithmic form, this is the exponential form. And for a function given by this, if I have a specific log, a log base e of x is also known as a natural log. So any logarithm, like we studied at the beginning of this lesson, any logarithm that is to base e is always known as a natural log, okay? So anything when I'm raising e to the power of any number, that's always known as a natural log. Now, these have all the same rules. We can use, as a normal logarithm, we can plug these into our calculator. So if I were to go in my calculator, there's actually a button that looks like this and has e to the caret. And if I go hit that and I type in, let's say, for example, e to the second power, if I type that in my calculator, then if not typing it into my calculator, but if I'm finding the natural log of 2, sorry about that, if I'm finding the natural log of 2, then I would literally type into my calculator ln of 2, and you can find the ln button, okay? And ln of 2 gives me this number 0.6931472. I could find the ln of 0.3, and that gives me negative 1.2039728, and I could plug in ln of negative 1, and that gives me an error. And if you remember from our study of logarithms, what these numbers are is I'm trying to find e raised to what power gives me these things in the parentheses. So here for this first one, I'm looking for e raised to what power gives me 2. Here I'm asking e raised to what power gives me 0.3. And here I'm asking e raised to what power gives me negative 1. And so here there is an error. I'll do this in red. There's an error because there's nothing that I can raise e to the power of to give me -1. It is impossible to get to -1 by raising e to some number. So these have all the same properties of a normal logarithm, but these, when we deal with natural logs, using natural logs, we actually use the properties of natural logs a lot more than we do logarithmic functions. And so I'm going to go over these again in detail, just like we did in the last section about the normal logarithmic function. Okay, so here we go. Number one, if you remember from last lesson, ln of 1 is 0, and that is because e raised to the 0th power is 1. Number two, ln of e is 1, and that should be pretty easy and intuitive to understand this because e to the first is going to be e. Number three, ln of e raised to the x power is going to be x, and if you remember from our properties of logarithms, e raised to the ln of x is also going to be equal to x. And if we write these in exponential form, these will be easy to see here for this first part. I rewrote that in exponential form. Remember that the natural log here is a specific type of log base e. So this should make sense to you on some level, because remember there's a little implied e here, that log base e, the natural log is log base e. So if I were to rewrite this in exponential form, I would be saying e to the x equals e to the x. So I'm essentially asking almost like this first. I'm asking this when I write this logarithm here in this way. I'm saying e raised to what power gives me e to the x, and obviously x, if y is x, then that will give me e to the x. So the natural log of e to the x is x, and in the same way, e raised to the natural log of x gives me x. Okay, and this is actually a very useful rule to use when we're solving equations that have either e or the natural log in them. If we're solving for x, you're going to have to use one of these two rules here, this one or this one, in order to isolate that x variable, and they come in handy, and you'll see that in future sections. And then the last one is this, the last property of natural logs is this: if ln of x equals ln of y, then that will only work if x and y are the same thing. Okay, so those are the properties of natural logs. If I'm going to use these properties, so for example, let's say that I had a problem and it said to use the properties of natural logarithms to rewrite each expression. If I had ln of 1 over e, and it said rewrite it using properties of natural logarithms, then I could see that I could rewrite this as ln of e to the -1 power. Anything raised to the -1st power is simply 1 over that same value. So 1 over e is the same as e to the -1st. And as we saw here in this rule, look at this. ln raised to e to some power just gives me that same thing. So here, ln e to the -1st, that's going to give me -1. So ln of 1 over e is the same as -1. Because if I take the ln e of anything, it's almost like, you can think about it this way, it's almost like these cross each other out, and all that's left is whatever's in that exponent. Whenever you see ln e of anything, you can imagine them crossing each other out. All that's being left is the exponent. But really what we're doing, we're not actually quote unquote crossing them out. We're using this property number 3 up here to just simplify this expression. What if it said e to the ln of 5? How could I rewrite that? Well, this one's actually quite easy. If you see up here, e to the ln of x equals x. So here, e to the ln of 5, clearly, I shouldn't write an error, I'll write equals. That would equal 5. Because if e to the ln of x equals x, then e to the ln of 5 must equal 5. If I had another one here that said ln e to the 0, what would that be? Well, clearly, if you were paying attention to our first example up here, this one right here, then ln e of anything, if I take the natural log of e raised to any power, that just gives me whatever the power is. So here that's going to be 0, because we're raising e to 0 and taking the natural log of it. And then one more here is 2 ln of e. How could we use the properties of natural logs to rewrite that? Well, again, here we have this ln of e that we keep seeing, and it doesn't have any power written up here, but we can tell that since this e exists, it implies that there's a 1 there. If these quote unquote cross each other out and they become whatever this exponent is, then 2 ln of e becomes the same as 2 times 1. And that just simplifies to 2. So there you go. That is the natural log and an introduction to the natural log. And you're going to be expected to be able to use these rules here, these properties of natural logarithms, to be able to simplify expressions like these here. And that is all.